Today we're going to talk about from Systrace to Safetynet, Android game development case studies. My name is Chris Foley. I'm a developer advocate working with games here at Google. And today I'm joined on stage by Damien Mabin, who is a game engine engineer from Supercell. And today, I wanted to talk about a few things. It's not just one topic, but it's actually a few topics about experiences that some of the partners that we've worked with have had in Android game development. And some of the topics that we'll be covering today will be Systrace. Then we'll also be talking about instant games. And thirdly, we'll be going over a few case studies and examples of how developers have used app licensing and Safetynet attestation API in order to safeguard their game. So first of all, wanted to talk a little bit about frame pacing and using Systrace to fix some issues that Supercell had with their game Brawl Stars. So up here is Damian, and Damian will be happy to walk through us what they did with frame pacing or fixing the frame pacing with Systrace. And I'll hand it over to him, and he can start over right now. And there we go.
Hey everyone, I'm Damien. OK, you might know at Supercell we have different teams that are fairly autonomous, and I work in the game engine team. So I am trying to help games team focus on what they do best, making the game. I'm trying to deal with like platform issues or like technical issues. And one of them is input latency on Android has been quite big. So let's while investigating input latency, one topic that came very quickly is frame pacing. So let's talk a little bit about frame pacing. It's just a very quick intro before we do more technical explanation. So here you see the yellow line is the timeline in the game, and the green bar are the vsync, when the display actually refreshes the image. And what happened in many games is the game is going to draw one frame, frame number 1 here, and at the end, it's going to put it, that bar is going to show the number of buffer being queued for displayed. So after drawing frame number 1, it's going to be unqueued for displayed, and hopefully it's going to get displayed at the next vsync here. While it's waiting for the first frame to be displayed, it's going to draw a second frame, which will get unqueued when it's finished drawing. And the game is not idle, so it's going to start drawing the third frame, which on Android will also get unqueued because Android allows triple buffering. So right now, we have 2 buffers in the queue waiting to be displayed, and 1 buffer currently displayed to the user. At the next vsync, frame number 2 is going to get displayed. Sorry, that's an interesting bit, actually. What should happen is that you should start drawing frame number 4 there. However, it's going to get delayed until after the vsync, because you cannot acquire 1 more buffer. Android doesn't allow it. It's only triple buffering. So after the vsync, frame number 2 is being displayed. Frame number 3 is still in the queue. And you can start draw frame number 4 because you can acquire 1 buffer. At the end of drawing frame number 4, it's going to get unqueued. And you are in a constant state of triple buffering right now. So the next frame is going to be drawn after the vsync, and you are going to unqueue it, and you are in a constant state of triple buffering. I guess the reason why it's bad is when you start considering inputs and the user feeling of latency between when the user touched the screen and do something and when it happened on the screen. So let's overlay on that this yellow-orange bar. This orange bar represents the time when Android tells us some input happened. It's actually tightly coupled with the vsync. So it happened a little bit after the vsync. And if you look at the first image and the first buffer and the draw one, well, the input happened after the drone has started. So you can imagine the game cannot really handle the input right there. So the game is actually going to consume the input only next frame, which will then be rendered during that frame, which will be unqueued, which will be consumed only in the next vsync. So here you are looking at a latency of one full vsync plus maybe 10 milliseconds, which is 26 milliseconds latency. It wouldn't be terribly bad. But if you look at a case where the game is triple buffering, for example, this one, you start seeing that between the time where you receive the input and the time where it is unqueued, there is maybe around 18 milliseconds roughly there. But it's unqueued. It's not the next buffer to be displayed. It's actually the second one. So you are looking at a whole end-to-end latency around 40 milliseconds, which start being noticeable as players, especially when you look at a fast-paced action game like Brawl Star. So what can we do? Well, let's take a look first at. Sorry, can we switch to the laptop,
Yep.
please?
Yeah.
Oh, yeah, cool. Let's take a look quickly at Systrace. So when I was investigating this issue, sorry, give me 1 second. OK. When I was investigating this issue, one thing I was, better. One thing I took really right away is Systrace. So from far away, it looks slightly scary. I'm going to try and explain a bit what's happening there. OK, so here at the top, you can see the CPU usage, which you can see have some spike on the bottom line that is pretty constant. There we can see details about what's happening on each core, but we don't care too much about it. And then there is two interesting bits in Systrace. The first one is something called Surface Flinger. You can see the name there. That's an Android process that is responsible for composing the final image drawn on the screen of your device. So if you use a normal app, you will see that most of the time you have the UI of the app, but you also have the notification bar at the top on some other element on the screen. So Surface Flinger is the one that takes the notification bar, the image of the app, put both of them together and display it on the screen. So we are going to look into a bit of the detail of Systrace later. And at the bottom here, we have com.supercell.brawlstar, which is the game I was profiling there. OK, let's go back to Systrace a little bit. And let's zoom a little bit. So the cool part of Systrace tool, if you open it in Chrome or whatever, you can navigate it the same way you navigate in a game. So W and S let you zoom in and out. And A and D let you go left and right, which is convenient. OK, let's take a look here. So the first thing to notice is these big gray and white bands are one frame being displayed on the screen. So if you try to measure, each of these is 16 milliseconds, right? It's running at 60 FPS. So yeah. And in Surface Flinger, there is one line here, surface view com.supercell, which is all the buffers that are being unqueued for rendering. So if I click on this one, for example, you can see there is a value of 2, which means there is 2 buffers in the queue. If you look at here, there is 1 buffer in the queue, which you can guess means we are triple buffering, 2 buffers in the queue, and 1 displayed to the user, which is pretty bad. It's the worst case I was explaining earlier. OK, and if we look a little bit more in Surface Flinger, you can see at the end of that vsync here, there is a whole lot of things that are happening in the UI thread. So this whole lot of things is what I was explaining. If I zoom a lot, you can see do composition here. It's taking the different buffer being displayed in the device and doing the composition to draw it on the screen. There is an interesting bit about it. If you look at that vsync here, you can see that our count of buffer in the queue dropped a little bit after the vsync, like about 500 microseconds. The interesting bit is naively, when I looked at it the first time, I would believe that drop would happen at the same time as the vsync. It's really interesting because what it means is that that buffer here is consumed by the UI thread about there when it's written acquire buffer. It's later being composed here, which means it's only going to be drawn there. We will see why it's really important a little bit later. But on Android, what happened is instead of consuming that buffer, instead of consuming that buffer here in order to draw it on the screen, it's consuming it here in order to draw it there, which have a small impact on how latency works, but I'm going to come back to it later. It's just interesting to notice that the hardware composition happened so much earlier than the vsync. OK, now let's take a look at the game. That's the current game that is currently live. If we looked at it, you can see our game there with our OpenGL thread. And you see our frame that is being drawn, undraw frame there. One thing that I discovered is at the top, you can see a scene line that is either green or red there. Red is meaning that our thread is sleeping and not doing any work. And green is meaning we're actually doing some stuff. So you can see this undraw frame is actually in a sleep state for a long while, like 6.5 milliseconds. And I was wondering what's happening there. And what's happening is that it's not able to draw because we are in that state of triple buffering, so we cannot acquire one more buffer. OK. Enough talk about the current state. Let's look at how it is after we did some fixes on the frame pacing. That's a trace that is taken after we did some fixes. The first thing that is interesting to notice is from far away. If you look at the surface flinger for the surface view, there is no more triple buffering. We are constantly in a state of double buffering. Here we have one buffer in the queue and then 0, 1 and then 0. So we are constantly double buffering. OK, as I was saying earlier, that frame being consumed here is being displayed at that vsync. Now let's take a look at what are the inputs being used to draw that frame, because that's really what matters here to reduce the input latency. So let me highlight that moment where we unqueued one buffer and look down in the game. So in that trace, I added a little bit of information about what's happening in the game. So you can see that at that time, we are swapping buffer. That buffer being swapped is being drawn there, and the logic of the game is being executed in the game update here. The interesting bit is, if I keep zooming a bit, the game update here is using the inputs that are delivered at that point here. So between that moment, when the frame was being drawn, when it has been queued, OK. So it has been queued here. It has been dequeued there. It will be rendered here on the screen. We are at about 32 milliseconds latency for the input, which is pretty much the best, at least I could find. If we look back at the previous game and we try to look at the same number, OK, here we have triple buffering. So let's take a look at this one. We have our undraw frame happening here, which is actually using the input being delivered the previous frame, which happened around here. And then if I look at the queue, it's being dequeued. This buffer that is unqueued there at the top is not the one being dequeued there. It's the one being dequeued at the next frame, which is actually being rendered here. So if I look at the overall input latency, we were looking at something around one too many, around 47 milliseconds. So we dropped about 1 frame of latency. Let's take a look at how it looks in the game in the end, because, well, that's what player experience is, right? I made a small video. I'm not really good at editing video, so it's not my primary skill. I did the best. So if you look very carefully, it's really clear, obvious, right? No, joking. I have a frame-by-frame thing happening. OK, so look on the left. Here we have our virtual joystick, and there, that white circle is where the finger is, or pretty much, it's actually displaying where Android thinks the finger is. So I am going to put my mouse on that white circle, and I am going to move forward by 1 frame. So you can see my mouse is still not under the virtual joystick. If I move by 1 frame more, now I have the virtual joystick under the mouse, which means that I have 2-frame latency between the user input and the game reacting to it. Now, if you look on the right, if you look here, for example, you have that's after the fix. So you have the user finger being here, and if I move by 1 frame, like the virtual joystick is on it, which means we have 1 frame latency in the display between the user input and the display on the screen. It's also interesting if I move a little bit forward or backward in time, actually. Sorry. If you look here, the distance between the joystick and the finger is quite big. If you look at this one, the distance is quite a lot shorter. Sorry, yeah, it's quite a lot shorter, which means that that also translates into the latency felt by the user. Yeah, that's the result of the input latency fix, 1 frame less. OK, can we switch back to the slide, please? Yeah.
We hop on back to the, yeah, thank you.
Yeah, so that's about it for my part on Systrace and dark art of Systrace and how to understand it. If you have any question, I am happy to chat after the talk.
Cool.
I am handing it back to Chris.
All right. Cool.
There you are.
Oh, yeah, actually, here, I had that water. Cool. Thank you, Damian. Yeah. Yeah, Systrace, it can be a little bit frightening at first, but it's a really powerful tool for really optimizing the performance of your game. So it's all available. I would encourage looking into it if that's something that you're really interested in and really making your game run smoother and really better. So moving on, I'm going to move into something a little more high level, and this will be instant game referral tracking. So let me first talk a little bit about why you would want to have instant games anyways. So the traditional game install flow looks something like this. There's a user acquisition event, like somebody clicks on an ad. They click on it, takes them to the Play Store. Nice big banner up at the top, install. And this is great. The player wants to try and play your game. The idea is they try it, they find it really exciting, and they want to play it. Or they go into it and play, right? But now they have to install. Now, that's actually a lot of friction right there. You know, it could be up to 100 megabyte download there, and maybe they're not on Wi-Fi, maybe they're on mobile somewhere. And if you're a game developer, I'm sure you all really know that really the end result is that often just getting an install can be the challenge. You know that once they play the game, they'll love it, but you can't even get to that point. So this is where instant games come in. So starting for your user acquisition flow, imagine you instead click, and instead of having to go to a store, it just immediately goes to, well, this screen right here, which is Google Play Instant, installing a game right there, and they have a demo version of the game. This is an instant game that they can play right away. There's no install. They're immediately into the gameplay experience. And you can use this moment to really sell your game to your player. And in fact, here on the top, there's a little button. It's hard to read here, but it says Install Now. And the instant game is where you prompt the player to actually install the game. But this is after they've had a chance to really experience it and really enjoy the game, and really this is why you've made the game in the first place. Once they actually decide that they want to try it, then you do the install. Then you actually prompt them, the game begins to download, but it doesn't matter so much at this point because you've already gotten the player involved and they're already really committed to it. Now, as I'm talking about this is obviously about optimizing user acquisition, and I'm sure that you all know, if you've done any user acquisition, that a key part of this is knowing your analytics, knowing your metrics, how effective are your different ad campaigns, knowing where your sources of those clicks are. But the issue is that if you have an instant game, just naively, the game will not know where that source is because there's that intervening step. And so if you look at the game from its point of view, it doesn't know where the source is. However, there's a way to fix this. And that is forwarding the referral from the instant game. So as it turns out, the instant game gets the same referral information that a regular game install would. So the problem, or really the issue, is at that point, you just have to collect that data and somehow get that to the full game. And this is how it's done. So you first collect the referral data by adding this code to the instant game's onCreate. And you can see we get the intent, we do a little processing about it. Then at the bottom, you pull the parameters out of the intent. And then here, they even add an extra parameter onto that, which is from IG, from instant game equals true. Then you include this referral data as an additional parameter for show install prompt, which is the part in the instant game where you actually are prompting the user, to obviously install the full game. And then the full game will get those parameters and then can use those to send those on and track your user acquisition referral information. So this is how it works in real life. So forwarding instant game referral strings, let's say we have ad campaign number 2, and here I have it, so say somebody in Colombia here clicks on an ad for your game. Now, the referral link will look something like this. This is obviously a generic one, but there's a link to the store. Now, at the bottom, you have your referral source, and it's a little bit URL encoded, but it says source will equal the ad campaign 2. That's where the source came from. And then down at the bottom is launch equals true, which tells the instant game to immediately start installing and downloading the game, which is what you want, lowers the amount of friction for getting into the game. Now, in the instant game, there's the code I just showed you that pulls the parameter out. Then at the bottom, you show the install prompt. Now, the full game now has the full information. It has the source, ad campaign 2, and there's even our additional source, which is from instant games equals true. Now you have even more information about your acquisition. And lastly, then of course you send that back to your own servers, your own analytics, and this is how you can actually see the full impact of your ad campaign and with instant games. So, on to my last topic today, which is talking about ensuring the integrity of your game. So, I'm sure you're all aware as game developers that you want people to play your game, that's great, but when you have a game out there, it's also going to attract bad actors, people who want to cheat, people who want to hack the game, maybe people who want to take advantage of other players or maybe hurt their experience. There's lots of different areas out there. And these all come in from different modes of attack, which are like modded APKs, or pirated APKs, or emulators out there, which are not bad in themselves, obviously, but can be used in various attempts too. You have rooted devices, once again, not bad in itself, but can be used to launch various attacks onto the game, such as memory attacks. And so if you're thinking about how do I keep my game safe? How do I protect the integrity? How do I protect my player base from having our ecosystem hacked in some way? And it really boils down to two parts. First of all, can the binary be trusted? In particular, did the binary come from somewhere that I trust? Is it from a known source? And the second part is, can the device itself be trusted? Because obviously, if you're just listening to the app itself, if the APK, and the APK says, hey, I'm great, I came from a great place, but you don't own the device, and the device might be hacked or modified in some way, that could change that. So you want to make sure that the device is okay as well. So for the first part, can the binary be trusted? There's app licensing. And for the second part, can the device be trusted? There's the Safetynet attestation API. And these two parts work together to help ensure the integrity of your game. And let me talk a little bit more about how this is. App licensing works like this. Say you have a game, and you want to know, was this APK downloaded from the Play Store? So the game at startup, you're launching, it's doing all its setup and initialization, and at this point, it calls the app licensing API, check access, which reaches out to the license verification server for Play and says, does the Google user here or does the Play user, have they ever downloaded this game from the store? Assuming it says yes, then it returns with a valid license, which triggers the license checker callback, and the player is allowed into the game. Likewise, suppose they don't have a license. Suppose they haven't downloaded the APK from Play Store. Maybe they sideloaded it somewhere. Maybe it was distributed somewhere else. Then it returns with no license, which comes back to the license checker callback, and you have a mechanism of keeping the player out of the game. The second thing is Safetynet integrity check. And this is a little bit more complicated. As I said, you don't really want to trust anything on the device if you're checking to see if the device itself has been compromised. So this has to be initialized from the back end. So in this case, here we have Brawl Stars and there's Supercell back end, and that initiates the check. It does that by sending a nonce, a small, unique ID that you're going to associate with this request all the way through this process. I'll get to the why in a second. The backend sends a nonce to the game. The game at this point uses that nonce, adds it onto the API call, which goes to the Safetynet attestation API on the device, which then forwards that back on to the Google attestation API backend. Now, this backend has a lot of different signals and ways of checking if the device itself has been compromised, or if it hasn't been certified, if it is not certified, or if it is certified. And it uses all these different signals to basically return back to you. It says, this device is good, or maybe it isn't so good. Whatever that response is gets sent back to the Safetynet attestation API, which then comes back to the game itself, forwarded back onto the back end. Now, the back end here is going to then check to see whether or not this is where you're checking the response here. Like I said, you don't want to trust the device just yet. So if you have a valid attestation and the nonce matches, now the reason you have that nonce is to protect against replay attacks, because there could be a hack, for example, that takes a valid attestation and responds back and says, hey, everything's good, even though it isn't. However, they won't have the correct nonce that you've attached with that, and that's why you initiate that from the back end. You will also want to check a few other things like timestamps, just in case something else is. There's a few other checks that you put into there. But assuming everything works out, says good, lets the player into the game. So this is how Safetynet integrity check works. So how does this work in the real life, and how can you use this to try your game? So I have a couple interesting cases here. The first is from Rovio. Now, Rovio has a game named Angry Birds 2, which maybe you've heard of. Now, obviously, Angry Birds 2, huge game, global, worldwide, and it also has a global leaderboard. Now, if you're thinking, is it a popular game and it has a leaderboard that everyone in the world wants to see, there are going to be a lot of attacks on this leaderboard because a lot of people want to cheat and get their name on the top of that leaderboard. So Rovio was seeing a lot of attacks coming in, and there were two main ways of attacking the leaderboard that they saw. The first was tampered APKs, modified APKs somewhere that people were sideloading. And the second one was a memory attack, and access to the memory of the game. Now, this is only possible on a rooted device. So this is a perfect use case for Safetynet, which is checking to see if the device has been rooted or not. Because if it's been rooted, then you can't really trust that the device is really as it always was. Maybe there was a custom ROM or something else. So Rovio implemented Safetynet attestation API, and the results were pretty good for them. What they saw was, first of all, right off the top, 40% fewer hack attempts on their leaderboard. I mean, if you think about it, that's 40% fewer attacks you have to defend against. It's a much more safer environment for their game. It's less that they have to work on. Whoops, sorry, clicked a little bit. It helps with their resource management as far as managing the game. It's less effort for protecting the game. And then second of all, what they saw were there was a higher degree of spenders in their top leaderboard, which, if you think about it, that this makes sense, and this is really what they wanted to see. Because you don't want to see hackers in the top of the leaderboard. You don't want to see people who are there, who don't really care about the game. They just want to show off like, hey, I'm great at this. Instead, the leaderboard was actually showing real players. People who were really committed and dedicated to the game. Those are the ones that you would expect to actually be on the leaderboard, and that's actually what Rovio got. So as a result, it really helped the game. It helped their community, helped their leaderboard, or helped the ecosystem of their game. They were very, very happy with the results. And then finally, for the last case I wanted to talk about today, which is reducing beta leakage with app licensing and Safetynet together. Now, first of all, what is beta leakage? So some people call it beta, some call it soft launch. But the idea is before you do your full launch, before you give your game out to the rest of the world, you might want to try a limited release. A soft launch where you have maybe a few territories where people are trying out the game, you start getting feedback on it, you start getting some information about the resources used by the game, maybe how many servers you need for it, and so on, and kind of see if the game is actually working like you think. So that's what your beta is, but you want to keep it limited. You don't want everyone out there because your game, this isn't really ready for the full world. But beta leakage is when that doesn't happen, where instead of having a few territories playing the game, now you have people from everywhere playing the game. And this can be really bad for your game management because now all of your projections on how much server usage or the demographics of your users or say the actions or the behavior of your audience are going to be completely out of whack from what you may have expected to begin with. And this is a real problem. Because, especially for games that are very, very, very popular, or really highly anticipated games, you get a lot of people who might want to get that APK even if they're not in one of those territories where they're allowed to. And in fact, one of our partners that we worked with saw a real issue with this. So they saw in our past Android soft launches that 90% of their beta users came from non-beta countries. Because they're able to see where these players were playing normally, but in this case, now when they want to play the beta, suddenly they're able to play even though they're not in that place. And the reason for this is that, Android is really open. That's very cool. That's one of the best things about the platform. And sharing APKs is also quite straightforward. You can pull an APK, you can share it around, distribute to your friends and so on, and maybe on different forums. And so really the challenge for the game developer who wants to keep their beta limited is how do you prevent your soft launch from unintentionally becoming a global launch? And this is where app licensing comes in and Safetynet. So as I mentioned, sharing outside of beta regions typically happens via sharing APKs. Now, in this beta, only the people that were in those few beta countries could actually legitimately download the APK from the Play Store. So if you had the APK and you're not from a beta country, you would not have a valid license for it. As a result, app licensing, which ensures that that APK actually came from the Play Store, well, that's the first thing you want to use, and that is how you can prevent people from playing the game in places where you maybe didn't intend. Now, as I mentioned, Safetynet, of course, is needed to check your device integrity, make sure that you can trust that app licensing to begin with. Now, what was the results of this? Well, the developer we worked with on this saw a huge reduction in the number of non-beta users. They saw 50% reduction in the number of their beta players who came from non-beta countries. And 50%, that's huge. The developer was really, really, really happy about this. And for me, this was actually the first time I'd seen a developer use this for locking down their beta. And I think it's actually a very, very interesting use case. So if you have a game that's coming out and you're worried about maybe keeping it only in a certain region, this is something I would actually take a look at. So finally, just kind of talk again about what I covered today. So first of all, we talked about Systrace, and Damian was very helpful on going through very in-depth on how they use Systrace to help fix some of the frame pacing issues they saw in Brawl Stars. Next, we talked about Instant Game and how you can forward your referral information from the Instant Game to the full game to really take full advantage of the increased user acquisition that Instant Games provides. And then lastly, we went over a couple interesting use cases of using app licensing and Safetynet to help protect your game and really protect your ecosystem against bad actors that might be out there. So with that, I'd like to conclude my talk. And first of all, I'd like to give a huge thanks to Supercell and Rovio for allowing me to discuss their games and use some of their images to help spice up my talk. And I'd also like to thank all of you for sitting through my talk and listening to me. I hope it's been instructive. And I would encourage you to look into these issues on the Play Store or in the Android documentation if you're interested. Thank you very much.